We're going to go through vertex form, and we talked about vertex form in the first chapter. And vertex form helped us graph quadratics. We're going to talk about why. Essentially, when we look at vertex form, first thing we're going to want to do is define each of the variables. So what would be considered my A in this equation? Good. 3 would be our A. What is our H? 5, -5. We'll talk about the difference between the two. And K is our +7. Now, because the reason they call this vertex form, does anyone know why it's called vertex form? It's very simple to find the vertex. And using these letters, what are the vertex? If this was my X and my Y value, what letters or variables could I plug in to say that? Okay. Where would I put which? So whatever the H value is the X value, and whatever the K value is the Y value? Are we sure?
No.
So does that mean the X value is -5?
No.
So it's the opposite. What operation can we put in front of H to help us remember that it's the opposite of that value? When I said negative H. Okay. So if it's a negative in there, and again, we've talked about before, remember this formula is technically a negative, right? So when I plug in +5, it's technically subtract +5, and that's why it comes out as a negative. So I want you to keep that in mind. It's just going to be the opposite of whatever number that is. So our H is our X value, and our K is our Y. So what is the vertex of this equation? +5 and +7. Good. Okay. It's +5 because our H is opposite. Now, with this information, I want to know if this opens upwards or downwards. Which way does this one open? And how do we know? How do we know it opens up? The A is positive. So because this A is positive, we know this opens up. Okay, so we're going to say it opens upwards. Okay? So in terms of the vertex, let's draw this now. I'll do a rough sketch. We know, is it going to be compressed or stretched? It's going to be stretched, very stretched. Okay, so if this is the vertex opening up, which way is the parabola? Is it this or is it this? The first one or the second one? Second one, that's right. Opening upwards means it is essentially the vertex is considered what? What would we call this? A minimum, exactly. So this is our minimum. Thanks, Sheldon. This is our minimum. Our minimum value, because it opens up, is whatever the Y point is. And the Y point, the lowest Y point in this case, is +7. So the minimum would be where Y equals +7. So in vertex form, it's very easy to A, find the vertex, B, find the minimum. What about the axis of symmetry? Anyone know what it is? The axis of symmetry is exactly the X value of the vertex. So the axis of symmetry is X is equal to +5. So there's a lot of information when looking at this in vertex form. There's a lot of information we can pull out of this. Okay, we're able to find the axis of symmetry. We're able to find the minimum. We're able to find the vertex. We're able to find which way it opens up or down. Okay. But what we haven't found from vertex form is the x-intercepts. I want you to think about this logically. Does this equation have an x-intercept?
Yeah.
No.
Yeah.
Where would they be?
I think yeah. I think yeah.
X-intercepts deal with what? Crossing what axis?
X.
Is this parabola going to cross the x-axis?
No.
No, so this one has no x-intercepts. So we've gone over the benefits of vertex form, okay? And we can quickly tell if there are x-intercepts or not. And there will be cases where there aren't any. Now, we can find x-intercepts using vertex form. This one, there aren't any, and I'll talk about the proof for that after. I'm going to use a different equation and then go back to that. So let's say this equation here, okay? -3 x minus 5 plus 7. Of course, it has to be squared. This one right here, the vertex is where? 5 and? Okay. Identical to above. Which way does it open? Down. Does this one have x-intercepts? Yes. It's going downward. So now we're going to talk about how to find the x-intercepts. X-intercepts are when y is equal to what value? That's right. So when y is equal to 0, is how we'll find x-intercepts. So, which of these variables represents our y? No, 7 represents the y value of the vertex. If we're just plugging in points, what represents y? The f at x. Okay. This here represents our y. So we're going to replace this with our value of 0. Okay. And then we're going to solve. So 0 is equal to negative 3 x minus 5 squared plus 7. To find x-intercepts, we need to isolate. I wish there were better colors. Let's try that one. We need to isolate. Oh, that's the wrong one. We need to isolate x. So we need to get x by itself, so I'm going to move everything to the other side. The first thing I would want to move is this positive 7. If I move it to the other side, what would it become? Okay, so we get negative 7 is equal to negative 3x minus 5 squared. What would be the next thing I want to move? Yeah, that's right. And this 3, what operation is it on the right side? It's multiplication. It says negative 3, but it actually means negative 3 times. Remember our distributive property? So in order to move it, that's right, I'll have to divide. So technically we would divide both sides, but the idea is that we'll have to divide by negative 3. So we get negative 7 over negative 3 is equal to x minus 5 squared. Now we're working with decimals. This is an uglier version, but that's fine. What's a negative divided by a negative? Positive. That's right. So this can technically be written as 7 over 3 is equal to x minus 5. What would be the next thing we want to move? The square. How do I move a power of 2? The root. It's called the root of it. So we're going to take the root. And even though it doesn't say it on your calculator, technically, because we'll get into this in exponents, technically a square root has a little number 2 here. And that tells us we need to find 2 numbers that multiply to this. Now, this is a fraction, so because you guys are probably not as used to using fractions, we can turn it into a decimal. We technically can find a root of a fraction, but we'll turn it into a decimal here. 7 divided by 3, okay? And I'm going to find the square root of that, all in one step in my calculator. 1.52. Yeah, okay, we'll round it to 1.53. Okay? So it's approximately approximately 1.53. We got rid of the root because we moved it to the other side with a square root. And it's x minus 5. Okay, but something I've missed out here. Technically, and I'll use an idea here. We did divide it by 3. The one thing I didn't do, what is the square root of, let's say, a number that we'd probably already know, 25? Is it just 5? Is 5 the only answer, positive 5? What's positive 5 times positive 5? 25. What's negative 5 times negative 5? It's the same thing. So there's actually 2 answers when we're finding square roots. It's positive and negative 5. So in this case, when we square root it, it's actually positive and negative 1.53. So at this point, we would split the equation. We have positive 1.53 is equal to x minus 5. And we have negative 1.53 is equal to x minus 5. So what that means is we're going to get 2 different x values. And let's go back up to our logic. How many x-intercepts should we have? 2. Okay, so we need to get 2. Right? There's not just one x-intercept in this question. So we'll continue a little farther. They're not nice whole numbers, but that's fine. We still have to isolate x, so I bring negative 5 over. It becomes 1.53 plus 5 is equal to x. And this becomes negative 1.53 minus 5 is equal to x. In this case, x is 6.53. That's one of our x-intercepts. And the other one would be... Oh, this should be a plus. Yeah, there you go. Sorry about that. This should be 3.47. Someone use a calculator for me there.
Yeah.
Nobody wants to do it? Okay, I'll do it. Oh, did I do that wrong? Oh, it's supposed to be negative, sorry. 1.53.
That's it, you're right.
I'm right? Okay, plus 5. Great. So our two x-intercepts, these are technically coordinates. The x values are 6.53. What's the y value? 0. That's one of them. And in our other one, we have 3.47 and 0. So we can use vertex form to actually find x-intercepts. We have to isolate for x. Set it equal to 0 and isolate for x. So let's go back up to our original question. How are we doing for time? We're okay. It's a little long. The original question. We said there's going to be no x-intercepts, correct? Okay. Let's try to prove this algebraically. And I didn't leave myself a lot of space. But we know we set this equal to 0. So 0 equals 3 x minus 5 squared. I have to bring over the 7, so it becomes negative 7 is equal to 3 x minus 5 squared. And then we divide by 3, negative 7 over 3 equals x minus 5 squared. And then to get rid of that root, we square root negative 7 over 3. Can I find a square root of a negative number? I can't multiply two identical numbers together and get a negative. So in other words, there's nowhere else I can go, right? This is the end. So I found no x-intercepts. Just like our theory told us, this should have no x-intercepts. This is our algebraic proof. We can't square root the negative value, so there's no x-intercepts for this question.
I don't know if it's the second or the fourth.